Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. Annubar selection and application. Welcome to this detailed session on Annubar selection and application. In this video, we will explore how the Annubar works, the equations behind its operation, criteria for selecting the right probe, practical installation requirements, and typical applications across industries. Principle of operation. The Annubar is a differential pressure flow meter that applies Bernoulli's principle. It measures both total and static pressure inside a pipeline. The differential, or dynamic pressure, is proportional to the square of the velocity. By multiplying the velocity by the pipe's cross-sectional area, we calculate volumetric flow rate. For mass flow, we include density correction. Unlike single-point pitot tubes, the Annubar has multiple sensing ports, averaging the velocity profile for greater accuracy. To make things clear, let's watch a short animation video about how Annubar flow meter works. The basic principle of operation for the Annubar flow meter is simple. As flow is moving down the pipe, it impacts the front side of the bar. This creates an impact pressure that is read by the slots in the Annubar sensor, capturing more of the flow profile for a more comprehensive and accurate measurement. This impact pressure is higher than the line static pressure. As the fluid flows past the bar, a low pressure is created on the backside. This low pressure is lower than the static pressure. The low pressure is sensed by the holes on the backside of the sensor. The difference between the high pressure reading on the front side of the bar and the low pressure on the back is the differential pressure sensed by the DP transmitter. Flow profile averaging. In real pipelines, flow velocity is not uniform. It is higher at the center and lower near the walls. A single-point measurement introduces error. The Annubar solves this by using several pressure taps across the diameter, delivering a true representation of the average velocity profile. This is especially valuable in large diameter pipes or where flow distortion is expected. Key advantages. The Annubar offers significant benefits: very low permanent pressure loss compared to orifice plates or Venturi meters. Cost-effective for large pipes, where other meters become impractical. Can be hot-tapped, meaning installation and maintenance can be done without shutting down the line. Suitable for liquids, gases, and steam, making it versatile across industries. Selection criteria, fluid considerations. Selecting the correct Annubar requires detailed knowledge of the process fluid. For liquids, viscosity and potential fouling must be considered. For gases, density, compressibility, and moisture content are important. For steam, temperature and pressure ratings must be carefully checked. Always select probe material compatible with the fluid, for example, stainless steel for water and steam, or special alloys for corrosive gases and acids. Pipe and flow conditions. Annubars are best suited for pipes 6 inches and larger, extending up to several meters. They require turbulent flow for accuracy, typically, Reynolds numbers greater than 20,000. To minimize profile distortion, industry standards recommend straight pipe runs of 10 diameters upstream and 5 downstream. If space is limited, flow straighteners may be required. Mechanical design and ratings. The mechanical design must match operating conditions. Probe supports must handle vibration and stress in high-velocity flows. For high-pressure or high-temperature steam lines, dual-supported probes are safer. Manufacturers provide standard and reinforced designs for different ranges, from low-pressure HVAC systems to supercritical steam in power plants. Accuracy and calibration. Accuracy of an Annubar system typically ranges from plus or minus 1% to 2% of actual flow, assuming correct installation. Calibration against standard flow rigs or field calibration improves confidence. Remember, installation errors such as misalignment with the flow axis or blockage of pressure ports can quickly degrade accuracy. Limitations. While highly effective, Annubars do have limitations. They are less accurate in laminar or transitional flow regimes. They may be unsuitable for fluids with heavy particulates that can block sensing ports. In small pipe diameters, their cost advantage disappears, and alternative meters like vortex or magnetic flow meters may be preferable. Applications across industries. Annubars are widely used in power generation, for measuring boiler feedwater and steam. Oil and gas, for pipeline monitoring of natural gas and crude. Chemical plants, for process liquids and utility services. HVAC and district energy, for chilled and hot water systems. Their combination of accuracy, durability, and low pressure drop makes them a preferred solution for high-energy, large-scale systems. Conclusion. In summary, the Annubar is not just a flowmeter, it is a robust engineering solution. Proper selection requires considering the fluid properties, pipe size, Reynolds number, pressure, temperature, and installation conditions. When chosen correctly, the Annubar provides accurate, economical, and reliable flow measurement across critical industrial processes. Thank you so much for watching and have a nice day.